other concepts or some keywords related to operating systems. We talked about processes, other states, level of processes, process image. What is process image? How do you understand this? Image of the process. Announcements? No, you don't know what is process image? Really?
RGB.
What?
RGB.
RGB?
Red, green, blue. Colors?
A little bit louder, please, because I cannot get it.
RGB, red, green, blue.
No. Image. No, not this image. No, I know. Image RGB, no, not at all. We do not go into computer graphics at all. Process image is the content of the memory of the process. So the process was running and there was taken kind of snapshot, for example, of this process. And all the content of the memory and register values, it was all stored in something which may be a process image. So this is the current state of the process. The state is represented by values of different types of memories. Main memory, register values. So this is process image. You may imagine that in process image you have everything which is required to resume such a process. Calculate once more from the phone. Then start writing in the file and resume it. But we also talk about process image about active process. When we hear process image, so how the process looks like running. So this is the state of the process. The state of the memory. Idea of child process. So one process is created, another one is the process which is created by the process. In unit, performed by the only one code which is called fork. The name of fork is because it looks like we have one path and from one place we have two paths. So it looks a little bit like a fork. And that process which is created is called child process. About the process which is creator, we usually describe it as parent process. IPC we mentioned, signals we mentioned, identifiers. Operating system operates different sets of identifiers. The names are, of course, the names as we see them as ASCII, they are for ASCII. They are translated and they have corresponding identifiers which are easy to operate by computer system, and these are identifiers. So each process has its own identifier. Each group, for example, of users of processes, process owner also has its own identifier. Identifier is a name. Identifier is a name from the definition, which will be always only related to that particular item, which is not true in operating. Because imagine that you have long relationships and they have their own process ID. And one process will be completed and another one is alive. After some time, in fact, the process ID may be reused for other processes. That sometimes means days or maybe weeks, who knows. But if the process is alive, suddenly, with the same process ID as other processes. So process ID, in fact, they are not identified because they may be reused. But we treat them as We treat them as identifiers. We assume that such situation never happens. But it happens. The idea of deadlock will be described on the next slide. Memory management. I hope that you understand that this is the role of the operating system to allocate and deallocate memory for processes. Input-output we discussed already. File we know. Directory, I hope we know. Access paths. What is access path? This is the path in the file system to locate, to reach the file. Yes? So this is, for example, the path from the root, or this is the path which is relative path from the current directory, and the Unix symbol of the current directory is dot. Root directory. This is the starting point of finding the files in our file system. Current directory. This is the attribute. Attribute of what? Attribute of user, or attribute of the process, or attribute of something different. When we log into our Linux Unix system, are we in one current directory? And if we have many windows with terminals, do they have to be in the same directory, those terminals? Not at all. So this is not the attribute of the user. So, which item possesses that attribute? This is the attribute of process. Each process has an attribute current directory. What is the idea of the current directory? Why it has it? What for?
Determine workspace of this process, maybe.
But for what?
To operate on files in other file systems.
So we may operate with relative paths starting from current directory. Yes? So this is the most important aspect of current directory, that we may operate with relative paths starting with dot. So from current directory in subdirectory B, for example. Yes? It also has other influence. It is treated as our resource. It means that, for example, if we try to unmount part of directory tree, which is a separate partition with file system, but there are processes which have as an attribute current directory on that particular file system, the action will be denied because that resource is in use. So it is treated also as a resource, and if we kindly ask the operating system will notify us. You cannot unmount that resource because it is still in use. Of course, if we unplug USB pen drive, yes, who knows what happens? File descriptor, this is the handler to the file when we have the file already available for us after action open. File system in general, this is the organization of files on some partition. Special files. Have you heard about special files? I know that you are on different levels of knowledge about Linux. Therefore, this is the way for me to get to know how many of you are more advanced and how many of you are not. So, who understands the idea of special file? Please, the hand up. Okay, this is my way of recognition.
Like DB files, maybe not.
DB files, no.
Special
Special.
paging files.
What? Paging? Maybe, but special files are entries in directory which look like a file but are in fact access points to something which is different to file. Which one? No, dots and two dots are treated as normal, regular files. No. One very commonly used special file is def null. If you redirect your output to def null, that def null is a special file. Def null as zero, as nothing, yes? If you redirect output of some process to def null, it means you try to hide it, to send it to nowhere. There is no such a file def null. It does not have limited space. This is the entry access point to some behavior or to some part of the kernel. In subdirectory dev from devices, we have special files. Def null, def zero, for example. This is the special file from which you may read stream of 0 bytes. Sometimes it is useful. Def random or def u random. These are the files from which you may read entropy, so random data. Or in fact pseudo-random. Some of them we have different random and u-random because from one you may always reach particular number of pseudo-random data, and the other one only takes data which are in a way produced for being pseudo-random. So if they are not produced on time, we have limited number of them. So this is the idea of special files. Block and character devices. In short, the difference is that in block devices, so we are talking about input-output. Block devices are those where you have the idea of addressing them. Go to block number, for example. Go to block number 1000. But imagine this sentence in context of keyboard. Go to key press 1000. This makes no sense. Yes? We cannot go, let's say, to 1000 key press in advance. Because on the keyboard we are in some place of string. There is no idea of addresses. That's why keyboard is called character device. Of course, all the disks are block devices. Because you have random access to them, you may give the address. Streamers are character devices. So on magnetic tape, you store in current position. Of course, there are some moves possible, but in a way, you are always in some position. The idea of pipe, which is very important. In general, idea of using Linux systems is to have a limited number of pretty simple tools from which you may, on demand, create pretty complicated sets of instructions in one line. That's why all the tools are simple in what they are doing. They have really strict goal. We rather do not have tools which are, let's say, general purpose tools.